Welcome to another tutorial on Matlab. In this tutorial series, we are looking into the basic concept of Matlab and how we can create a desirable M script. In the starting, we are looking into the concept related to row vectors and column vector, which we have already seen in the previous video, how to create a row vector and how to create a column vector. And based on that, we also seen some of the operations like extracting elements from the row and column vectors. Along with that, we also seen how we can transpose the row vector to column and column to row. In this particular tutorial, we will see like how we can apply multiple operations like mathematical operations and function operations inside MATLAB, and how basically it gets implemented in the software itself. So if you consider MATLAB, then you already know that it is called a matrix laboratory. So based on this, you can consider that whatever the variables that you create are by default a matrix. So you can see on the left hand side in the picture that we seen like if we create a row vector, then it will have a single row. If we create a column vector, then it will have a single column. So based on this, if we combine both of the properties, then we get a matrix. This is the default structure that the MATLAB creates for any variable. Based on the dimension, it creates the variable, but by default, all the variables are treated as row vector, column vector, or a matrix. So if you see the mathematical operations, consider an operation which is more like a addition operation or a subtraction operation. So in that case, what you can have is like you create a vector A, which could be, for example, this one. And based on that, you also create another vector. And when you just type A plus B, then you will get the resultant vector C, which is a addition operation of corresponding elements. Like here, you can see 35 plus 1, 36. 95 plus 2 is 79. 72 plus 4, 76. And 84 plus 9, 73. So you don't need to do this with the help of a for loop, but this will be taken care automatically in MATLAB environment, because every data type that MATLAB creates is a type of matrix, which is by default will operate based on a matrix data type. So this we will see now in the MATLAB environment. So let's jump into the MATLAB environment now. So let's create the first vector A and then the second vector B, and then we do some addition operation and get the vector C. So we create a vector A equal to, let's see the elements now. So 35, 95. So we'll have 35, 35, comma 95. So as we mentioned it as column vector, so we will use semicolon. And now it's 72 and 84. So 72, semicolon 84. So this is the column vector that we created. So the first one, now we create the second one, which will be the B vector 1, 2, 4, 9. So B will be equal to 1 semicolon 4 semicolon 9, and 2 is missing, so we will put 2. Yeah, so we do have two vectors now. Now suppose I want to just type A equal to, or suppose I want to type C equal to A plus B. So I'm just doing an addition operation, but the MATLAB environment is designed in such a way that this will add up all the elements and you will get the resultant vector as which we see 36, 97, 76 and 93. So if you add the individual elements, then this will be happening. Same happens with the multiplication operation, but in case of multiplication, you need to use a dot operator and then multiplication. So if you do this, then you will get element-wise multiplication. This will be the outcome of the multiplication. If you don't use dot, then you will get an error. That will be a matrix multiplication operation, and in that dimension should match. So if I type C equal to A into B, A into B, then I will get error due to the dimension. So that we will cover specifically when we will be dealing with a matrix related operation. But the main concept over here is whenever you want to do any element wise operation, in that case, you will be getting the entire operation at one go. Like you can see, all the elements are getting added in the add operation and we are getting a final vector. So this is an advantage which you can use to do any computation. Suppose you have a big chunk of data that you can put in a vector, could be a column vector, and then you can put some other elements in another column vector, and you can do add that without using for loop. So if you don't use for loop to do this element wise addition, then in that case you are increasing the efficiency of your program, so that will respond more fast and you will get a quicker response from your program. So it is not like you just do one operation like this. Maybe you will be doing big multiplication or addition operation for very large data set. So in that case, the program will get slow. So this efficiency or this capacity of the MATLAB environment, treating every data as a matrix or a vector, is a good advantage which we can use and increase the robustness of our script. So till now what we discussed is about mathematical operations. So now we will clear the screen as well as clear all the variables. So if you type clear, then everything will be cleared on the workspace. You are not able to see any variables now. Now type CLC, you will be having no variables available. And also the screen is clear. Now let's jump into the function operation. So suppose I have a vector which I want to implement some function. So what function will also do, like the addition operation, it is taking all the elements at one go. Same way, the function implementation also happens for any type of functions, which could be a user-defined function or which could be a MATLAB inbuilt function. So we will see this later on when we cover the function part. But over here, what is the main point is whatever the data, it could be a matrix, it could be a row vector, or it could be a column vector. If you pass it on to that function, the function will implement the operation, whatever it is meant for, right, to all the elements. So let's see that in the MATLAB environment. So now suppose I create a same vector, maybe which I used to create any older command or to implement any older command. You can just press the upper arrow key. It will show you all the relevant commands. So suppose this is my a vector that I created last time. Now I want to apply function to this. So what I need to do in this case now? So now I can apply a function which could be like a sine function. It will be applied on the vector A and it will be applied to the individual elements of A. So let's store that variable in variable C, and let's do some sine operation. So sine cos operation. So this is the sine operation, and I will just pass on the variable A. So what it will do the operation based on the individual elements. So sine of 35 will be this value, and sine of 95 will be this value, sine of 72 will be this value, and sine of 84 will be this value. So that way it usually computes, and you are also getting a sine operation at one go in a vector format or in a matrix format. So why I'm using it interchangeably is because here we have only one column. We do not have any two column in this particular data set. So that's why I'm using the word vector. But when we study the part matrix in this particular tutorial series, then in that case, we will be also looking how it will be dealing with matrix. So that is coming next in this tutorial series. So coming to the summary, what we seen in totally is we seen in the previous video that we do have two types of vectors. One is the row vector and one is the column vector. And then we also seen like what is basically a matrix. It is a combination of row and column vector. And then we seen some of the basic mathematical operations like addition operation we also seen one example of mathematical operation, and the dot operator, dot multiplication, which does the element wise multiplication. And we also seen some error get generated right in doing direct multiplication, which we will see in case of matrix dimensionality related error. And next we seen mathematical function related operations on the vectors. So how you can treat like how you can operate the entire individual elements one by one by just calling one line, and that is the advantage that you get in the MATLAB. So the main agenda of having this video is to make you understand the power of MATLAB, like how you can leverage that power, and how you can use that in an efficient and computing program creation, which will make your task more easier when you are dealing with very complex solutions like bigger matrix. So in case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. We will be more than happy to clarify your doubts. Have a great day ahead, and thank you and happy learning MATLAB. Take care.